Dear friends, in the last class we are discussing about types of functions. That means one function and onto functions. Okay, our definition also you are very well known. Okay, so in the last class I am telling you about one of the method to verify whether the given function is onto or not. So that is if codomain is equal to range. So codomain is equal to range. This implies given function f is onto functions. F is onto. So suppose if codomain is not equal to range, so then this implies f is not onto. Already in the last class we are discussing about that. Okay. So one more working. So some of the problems we are also going to solve using this method. Some of the problems are solving this method directly. If we are verifying codomain is equal to range, so then it is obviously the given function is onto function. If codomain is not equal to range, so then it is that onto function. So one more working rule is here. So observe that. So procedure is very important. If once we know the procedure, then it is easy to verify whether the given function is one or not. So see here, first, suppose let f is mapping from a to b is function. So function given, f is mapping from a to b is a function. So step 1, let us consider an arbitrary element y in b. So y in b is the given. We are considering an element y which belongs to codomain. Okay, that is the first step. And next, second step is put f of x is equal to y. Put f of x is equal to y. Third step is solve for f of x. Solve f of x is equal to y for x in terms of y. So you are going to solve the function f of x for x in terms of y. That is, we get f of y is equal to x. F of y is equal to x. So I am writing here, suppose, okay. So here f of x is equal to 4x plus 3 is base. Suppose this is a given function. Okay. So I am taking, so f of x is equal to y. So f of x is equal to y. So that is, so it become what? So y is equal to 4x plus 3. Y is equal to 4x plus 3. Solve this equation. So this means the third step is solve f of x is equal to y means solve this equation for x. That is, we are getting the equation in terms of y. That is, the x is the function of y. So here, first is y is function of x. We are getting x is function of y. So that is, so keep it here. 4x is equal to y minus 3. So x is equal to y minus 3 divided by 4. So this is x. So that means, so solve for x in terms of y. See here, x is equal to y minus 3 divided by 4. So this is the equation in terms of y. That is in terms of y. Okay. Next, if for all y belongs to b, suppose here we are taking an arbitrary element, any one of the arbitrary element. But suppose if you consider all any elements belongs to the function, the set b, that is codomain, there exists f of y is equal to x. There exists f of y is equal to, so this is f of y is equal to a y minus 3 divided by 4 is an element of A. Suppose I am taking, so here f is mapping from n to n or q to q. Set of all rational number to rational number. Okay. So suppose I take any element belongs to codomain. So this is codomain. Okay. This is domain. Okay. This is domain. Suppose I take any one of the elements. Suppose one belongs to Q. That means codomain. Okay. So if I am putting f of y, that is f of 1 is equal to y minus 3. That is y is equal to 1 minus 3 divided by 4. So this become minus 2 divided by 4, that is minus 1 divided by 4. So this is belongs to Q. This is belongs to Q. That means what? Domain. Domain. Is it clear? Suppose we are taking any elements in the codomain. Suppose if we are taking any element in the codomain, then there exists an element. After solving this, then there exists an element. Suppose here minus 1 by 4. So which is belongs to the set Q. That means every elements in this set. So every elements in codomain has pre-image in domain. So the definition of onto function you are very clear, right? So suppose f is varying from A to B is said to be onto function. So if every element of B are images of some element of A, or every element of B has pre-image in A. Every element of B has pre-image A. So this gives the same meaning. Okay. Suppose we take any value. Suppose if I take 2 belongs to Q. Okay. That means codomain. I take any arbitrary limit. 2, 3, 4, minus 2, minus 3. Whatever the elements we take, that must belongs to codomain. Solve this equation. That means put y is equal to 2 in this equation. Okay. So that is f of 2 is equal to 2 minus 3 divided by 4. That is minus 1 divided by 4. So is it clear? So this belongs to Q. This is also a rational number. This belongs to where? Domain. Is it clear? So that means every element in codomain has pre-image in domain. Every element in codomain has pre-image in domain. Suppose if I define this function, suppose same function, if I define natural number to natural number. Okay, I take suppose instead of taking Q natural number, so I take natural number to natural number. What happens? So see here. So if I take natural number to natural number, okay, so natural number to natural number. Okay, so observe here. I am solving same equation. So f of y is equal to y minus 3 divided by 4. So 1 belongs to natural number. Yes, already you are clear that 1 is a natural number. So this is belongs to codomain. Put this one in this equation. So f of 1 we get minus 2 by 4. Is it minus 1 by 4 belongs to natural number? No. So this is not belongs to natural number. So this means what? This means so 1 belongs to codomain has no pre-image in domain. That means it does not satisfy the definition of onto function. Okay. So therefore f is varying from on to on is defined as f of x is equal to 4x plus 3 is not onto function. Is it clear? So purely on the basis of definition, if we take the same function, f of x is equal to 4x minus 3 on q to q. If you define this function from f is varying from q to q, this is onto function. Because so every element in codomain has pre-image in domain. Okay. Suppose if we define the same function f of x is equal to 4x plus 3, natural number to natural number. If is varying from natural number to natural number, so then it is not onto function. Okay. So that is not onto. Why? Because so some of the elements. So we are given one counter example. Any one of the counter example. So this is not satisfied. So therefore it is not onto function. Whether you take 2, yes, 2 is natural number which belongs to codomain. Is it? So f of 2. So 2 minus 3 divided by 4 minus 1 by 4. So this is not belongs to natural number. That means 2 in codomain, but has no pre-image in domain. Now clear ಆಯ್ತಾ? ಅಂದ್ರೆ ಪ್ರತಿಯೊಂದು ಕೋಡೊಮೈನ್ ಇರತಕ್ಕಂತ ಪ್ರತಿಯೊಂದು ಎಲಿಮೆಂಟ್ಗೂ ಪ್ರೀ ಇಮೇಜ್ ಎಲ್ಲಿರಬೇಕು? ಡೊಮೈನ್ ಅಲ್ಲಿ ಇರಬೇಕು. ಹಾಗಾದ್ರೆ ಇಲ್ಲಿ ಏನಾಗ್ತಿದೆ, ಇದೇ ಫಂಕ್ಷನ್ ಅನ್ನು ನಾವು ಕ್ಯೂ ಟು ಕ್ಯೂ ಡಿಫೈನ್ ಮಾಡಿದಾಗ, ರ್ಯಾಷನಲ್ ನಂಬರ್ ಮೇಲೆ ಡಿಫೈನ್ ಮಾಡಿದಾಗ ಇಲ್ಲಿ ಪ್ರತಿಯೊಂದು ಎಲಿಮೆಂಟ್ ಇರ್ತಕ್ಕಂಥ ಎಲಿಮೆಂಟ್ ಪ್ರೀ ಇಮೇಜ್ ಇದೆ. ಹಾಗಾಗಿ ಇದನ್ನ ನಾವು ಆನ್ ಟು ಫಂಕ್ಷನ್ ಅಂತ ಕರೀತಾ ಇದ್ದೀವಿ. ಬಟ್ ಇಲ್ಲಿ ಏನಾಗ್ತಾ ಇದೆ, ಸಪೋಸ್ ನ್ಯಾಚುರಲ್ ನಂಬರ್ ಟು ನ್ಯಾಚುರಲ್ ನಂಬರ್ ಡಿಫೈನ್ ಮಾಡಿದಾಗ ಏನಾಗ್ತಾ ಇದೆ, ಸೊ ಇಲ್ಲಿ ಕೆಲವು ಎಲಿಮೆಂಟ್ ಸಪೋಸ್ ಒಂದಂತಕ್ಕಂಥ ಒಂದು ಎಲಿಮೆಂಟ್ ಇದೆ, ಇದನ್ನ ಇದರಲ್ಲಿ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿ ಸಾಲ್ವ್ ಮಾಡಿದಾಗ -1/4 ಅಂತಕ್ಕಂಥದ್ದು ಬರ್ತಾ ಇದೆ. ಸೊ ಇದು ನ್ಯಾಚುರಲ್ ನಂಬರ್ ಇಲ್ಲ. ಅಂದ್ರೆ 1 ಅಂತಕ್ಕಂಥ ಎಲಿಮೆಂಟ್ ಓ ಡೊಮೈನ್ ಅಲ್ಲಿ ಇದೆ, ಆದ್ರೆ ಇದು ಪ್ರೀ ಇಮೇಜ್ ಆಕ್ಚುಲಿ -1/4 ಬರ್ತಾ ಇದೆ. -1/4 ಅನ್ನೋದು ನ್ಯಾಚುರಲ್ ನಂಬರ್ ಇಲ್ಲ. ಸೊ therefore so this is not onto function. Is it clear? So write down the working group first. On the basis of this working group, we are going to solve this type of problems. Okay, write down. Just write down working group only. Okay, so this is just for explanation for this working group. So I am going to solve the same problem in the next one. Okay, first writing working group. It is better to take screenshot. Okay, then it is very easy to write. Okay. If f is matching from q to q and f is given by f of x is equal to 2x minus 3. X from x belongs to q. Verify f is on to or verify f is on to or. Okay, so I have done this. Same problem. So we are going to solve the problems using the working group. Okay. So solution. So observe here for a very problem. Double given problem. First we observe the function is different from where to where. It is very important. Whether the function is different from natural number to natural number, real number to real number, or rational number to rational number, whatever it may be. First we observe carefully. So that is f is mapping from q to q is here. Okay. So f of x is what? F of x is equal to 2x minus 3. 2x minus 3. Is it clear? Step 1. First step 1. What is the first step? So just we are taking an arbitrary element which belongs to q. That means codomain. Okay. So like y belongs to q. Y belongs to. So So q is y belongs to q is nothing but this is also q, this is also q. But we are taking the element y, an arbitrary element in the codomain. In the codomain. Okay na? Put next step. Put f of x is equal to y. F of x is equal to y. So f of x is already here. That is 2x minus 3 is equal to y. Okay. Third step is what? Solve for f of x. That means solve this equation for x. That means we are getting x. We are getting in terms of y. X is in terms of y. So that is 2x is equal to y plus 3. Okay. So x is equal to y plus 3 divided by 2. Okay. So this is in terms of y. Okay. X is in terms of y. So clearly we observe that. So see here. Clearly we observe that, or we have verified that for all y belongs to codomain. So suppose we are taking any element which belongs to codomain, there exists an element. Is it suppose if we put 1, then we exist one number. If 2, we give exist one number. So suppose if 3, so then we get one number. Or if we put y is equal to 100, then also we get one number. That is for x. So this value must be belongs to q for f is order function. Suppose we are telling the given function is f is varying from q to q is order function. Definitely, the whatever the value, suppose we put for y in the codomain, then there exists element that also belongs to y. Okay. So you know y ಏನು ವ್ಯಾಲ್ಯೂ ಆಗ್ತಾ ಹೋಗ್ತೀವೋ ಆ ವ್ಯಾಲ್ಯೂ ಸಾಲ್ವ್ ಮಾಡಿದ್ರೆ ಬರ್ತಕ್ಕಂಥ x ಗೆ ಒಂದು ವ್ಯಾಲ್ಯೂ ಬರುತ್ತೆ. ಆ x ಅಂತಕ್ಕಂಥ ಎಲಿಮೆಂಟ್ ಎಲ್ಲಿ ಇರಬೇಕು? ನಿಮಗೆ q ಅಲ್ಲಿ ಇದ್ರೆ, q ಅಲ್ಲಿ ಇದ್ರೆ ಡೊಮೈನ್ ಇದ್ರೆ ಆ ಫಂಕ್ಷನ್ ಗೆ ಪ್ರತಿಯೊಂದು ಇರತಕ್ಕಂಥ ಎಲಿಮೆಂಟ್ ಗೆ ಇಲ್ಲಿ ಪ್ರೀ ಇಮೇಜ್ ಇದೆ ಅಂತ ಆಗುತ್ತೆ. ಹಾಗಾಗಿ ಸೊ ಏನಾಗುತ್ತೆ ಅವಾಗ ಆನ್ ಟು ಫಂಕ್ಷನ್ ಆಗುತ್ತೆ. ಹಾಗಾಗಿ ಸೊ ಕ್ಲಿಯರ್ಲಿ ಬರೀತೀವಿ. ಸೊ ಕ್ಲಿಯರ್ಲಿ we observe that. For all y belongs to q. For all y belongs to q, then there exists f of x. That means f of x is equal to y plus 3 divided by 2 belongs to q. Q is the domain. This q is codomain. This is codomain. Okay. So clearly, for all y belongs to q codomain, then there exists x is equal to y plus 3 divided by 2 belongs to q. That is belongs to where? To the domain. Okay, so that is in the f of x is equal to y. F of x is equal to y. Okay, so f of x is what here? F of x is nothing but 2x minus 3. Okay, so x is nothing but y plus 3 divided. Suppose if you put x y plus 3 divided by 2 in this equation, then we get f of x equal to x. Therefore f is onto function. F is onto. That means so every element in the codomain has pre-image in domain. Okay, so write down this. pre-image. Q domain. So that means for all elements Q, that means codomain has pre-image in Q. So therefore F is on. F is on. Is it clear? So next problem. Suppose I take the same problem for natural number to natural. Suppose F is matching from natural number to natural number. Okay? And F is given by f of x is 2x minus 3. Then for all x belongs to n natural number. Okay? So verify F is on to or not. F is on to or not. Okay? So change this. So natural number to natural number to natural number. Okay? So f of x is equal to x minus 3. So let y belongs to q. That means y belongs to q is equal here natural number. Okay. Second step is solve. Put f of x is equal to y. That is 2x minus 3 is equal to y, and x is equal to y plus 3 divided by 2. Okay. Here just we change domain and codomain. Okay. Now then we observe what happens. So clearly we observe. So you can change it. Okay, so suppose then like we take any unit. Okay, suppose we take y is equal to 1. If we take y is equal to 1, okay, so y is equal to 1. So then what happens? So x is equal to what? X is equal to 1 plus 3 divided by 2. That is x is equal to what? So 4 by 2 is equal to 2. Okay. So on the basis of this only we are not telling this order function. Okay. So just we are giving one counter example. Suppose instead of taking 1, suppose I take 2. Okay. So let y is equal to 2. Let y is equal to 2. This is belongs to natural number. That means codomain. 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 Y is in one of the natural number. Okay. So what we know? Then x is equal to 2 plus 3 divided by 2. Then x is equal to 5 by 2. So 2 belongs to natural number, but x is equal to 5 by 2 not belongs to natural number. Not belongs to natural number. That means not belongs to domain. Not belongs to domain. Is it clear? So this is one of the element. That means here, so natural number. So 1, 2, 3, 4, 5, 6 and so on. So 1, 2, 3, 4, 5, 6, 7 and so on. So natural number to natural number. Okay. So 2 is element here. Okay. 2 has here 2. I take 2. 2 is the element of natural number. Has no pre-image. Observe. Is there any pre-image? Is there any pre-image? No. No pre-image. 5 by 2 is not belongs to them. Illa. Natural number illa. Agagi. So this is not on the function. Therefore, f is not onto function. Okay. So right. Just by taking these two examples, I think you are clear about the difference of one and another function or definitions. Okay. Correct. Okay, clear? So some of the problems are discussing after the discussion of bijective function. Okay, so next one is bijective function. Bijective function. Bijective function. Okay. The function, if p is mapping from A to B, is said to be bijective function. Bijective function if f is both 1 1 and 1 and on 2. So it means any of the function is said to be bijective, or the function f is mapping from A to B is said to be bijective if it is both 1 and on 2. That means ಯಾವುದೋ ಒಂದು ಫಂಕ್ಷನ್ ಅನ್ನು ಬೈಜೆಕ್ಟಿವ್ ಕರಿಬೇಕು ಅಂದ್ರೆ ಅದೇನಾಗಿರಬೇಕು, it is both 1 and on 2. That means it is both injective and subjective. And if the function f is mapping from A to B is said to be bijective if it is both injective and subjective. Clear? So then this is called a bijective function. Write down the definition. Next problem is show that the Signum function f is mapping from R to R given by f of x is equal to 1 if x is greater than 0 if x is equal to 0 and minus 1 if x is less than 0 is neither 1 nor on 2. Okay, so that the function Signum function. Okay, right now. So see here, show that the function Signum function. Already you know that Signum function. The first year we are discussing about that. So Signum function, f is mapping from R to R. So given by f of x is equal to 1, if x is greater than 0. Suppose here we are putting the any real number greater than 0, then f of x is equal to what here? 1. Suppose if x is equal to 0, suppose if we put x is equal to 0 here, okay? F of x is equal to minus 1 if whatever the value was given to x is less than 0, negative real number. For any negative real number, we get minus 1. For any positive real number, we get 1. And 0, we get 0. Okay? See, it's neither 1 or 1. Okay? So, solution. Okay, first we have to write the function f is mapping from R to R. F is mapping from R to R. And define f of x is equal to 1 if x is greater than 0 if x is equal to 0 minus 1 if x is less than 0. Okay, we have to verify whether it is 1 1 or not, or show that it is not 1 1. What is the definition of 1 1? So different element of A has different images. The definition is that suppose f is mapping from A to B, f is mapping from A to B is said to be 1 1 function if different element of A has different images in B. We have to verify whether different element of A has different images in B. Okay, so see, suppose I take one arrow diagram. Okay, so this is real number to real number, real number to real number. So here I take real number. Okay, 1, 2, or 3. Real number. Whatever the value, I take possibly real number. Okay, so what is the output? Suppose if you put f of 1, then answer is 1. That means this 1 is mapping with 1. Suppose I put x is equal to 2 here. X is equal to 2 is equal to x is greater than 0. So therefore f of 2 is equal to 1. Says this is related with 1. Suppose I put 3. So this is also 1. So observe here. It is not satisfied the definition of 1 1 function. That means one or more element have same image. One or more element in the domain has same image. Okay, so therefore that is f of 1 is equal to f of 2 is equal to f of 3 is equal to 1. Therefore f is not 1 2, not 1 1, not 1 1. Clear that? So we are also solving this example by using working rule also. Okay, now working rules means what? We are taking two elements. Okay, so that is 1 is not equal to 2, 1 is not equal to 2. Is it? But f of 1 is equal to f of 1 is equal to f of 2. But when you get f of 1 is equal to f of 2. Okay, so therefore that is f of 1 is that equal to 1? This is also 1. So therefore f is not 1 1. F is not 1 1. How to derive the working rule? X is equal to x1 is equal to x is equal to y. If we get f of x is equal to f of y, so then that is 1 1 function. Okay, x is equal to y. If you get f of x is equal to f of y, okay, or f of x is equal to last finally you get x is equal to y. So then it is 1 1 function. Then it is 1 1 function. 1 1 function. Or x is not equal to y. Okay, f of x is not equal to f of y. So then also, so this is also 1 1 function. Same. Suppose if we take x is equal to y. Okay, x is equal to y. Finally we get f of x is not equal to f of y. So then this is not 1 1. Not 1 1. Okay. So same. Here also same. Okay. So next you have to verify whether you will show that it is not onto function. Onto functions. Onto function. Okay. So onto function is equal to codomain is equal to range. Okay. So here f is mapping from R to R means, okay na? So codomain is what? Codomain is the given set of R real. Okay. So what is the range of signum function? Range of signum function. Range of signum function. Range of signum function is what? So 1 minus 1 0 1. Clear? Okay. So whatever the value is given to the this function f of x, only we get 1 0 minus 1. That is the given range. Okay. So observe it. Codomain is not equal to range. So codomain, therefore codomain is not equal to range. Not equal to range. Therefore f is not onto. Okay. So clear? It's two more problems. So for solving this, just giving one example. Whatever the value, take minus 1 2 3 or minus 1 minus 2 minus 3, whatever the value you take. Just we give a counter example for proving not known function and show that codomain is not equal to range, so then it is not onto function. Okay. So this is clear. So in the next class we are discussing some more examples on the same concept, 1 1 and 2 and basic. Okay. Thank you.